Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at quality of service models. We'll be discussing the quality of service models, selecting an appropriate quality of service policy model, best effort, integrated services, and finally differentiated services. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. When we look at the different mechanisms for quality of service, we have to look at what type of model are we going to use. For our best effort model, this isn't really a quality of service. It's more of, okay, we're going to do the best we can. If we get overloaded, we're just going to slow everything down until the congestion clears up. You use this when quality of service is not needed. You have a simple network. You don't do a lot of voice or video on that. This would be an appropriate model for you. Next, we have our integrated services model, or we call it INSERV. This is an automatic QoS. It provides a really high quality of service for IP packets, and it also guarantees the delivery. Now, it defines a signaling process for the applications, and they signal the network here that they require a special quality of service for a period, and that bandwidth should be reserved. So they signal the network and say, hey, I need so much bandwidth to send this data, give it to me. Now, INSERV is very resource intensive. Because it's resource intensive, when you try to scale this onto really large networks, it just doesn't work because of all those requests to make that dedicated bandwidth happen between point to point. The last model here is the differentiated services model, or DiffServ. Now, this is a quality of service model. It gives really high scalability and flexibility, but it is a manual process. You need to go into your devices, configure quality of service there. The network devices then recognize traffic classes. So they look at these classes and say, okay, this is a high priority class, this is a low priority class, and then provide different levels of QoS to those different classes. So it's a manual process. Because of that, it scales very, very well in flexibility, but you as the administrator have to go in and set it up initially. When we look at the best effort model, there's some benefits and drawbacks to it. Here in the benefits, this model, the best effort model, is the most scalable. It's the easiest to add more devices in, and it's a really easy process to add them in, and we can grow that to a very large network. Now, our scalability is only limited to the available bandwidth. So the bandwidth we have is the bandwidth we have, and that's it. And once that bandwidth gets full, all traffic is going to be equally affected. Voice, video, static web pages, they're all going to be slowed down by the same amount until that congestion clears off. Now, it's also a benefit here that there's no special mechanisms that are required. You don't have to go around and set up anything on the clients, on your networking devices, and it's the easiest and quickest model to deploy because basically you're not really setting up quality of service. You're doing normal configuration on your devices, you're not doing any QoS, and you're just letting the device handle it with a standard clear configuration where if it gets full, it's just going to slow everything down and get the data through. Now, there are drawbacks. There is no guaranteed delivery, so it's not going to make sure data makes it to its end. The packets are going to arrive whenever they can and in any order, so there is no ordering that happens with there. And once again, if they arrive at all. No packets have any preferential treatment, so voice doesn't make it through your network faster than static data. Critical data, once again, is treated the same as a casual email or web page that is traveling through your network. I hope you're enjoying this episode on quality of service models. If you have the time, please leave a comment and let me know what you think about quality of service models. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. When we consider the integrated services model, it has a tighter quality of service for real-time traffic, meaning you can control it a lot better. And it's a very good system. Integrated services model uses something we call RSVP, Resource Reservation Protocol. This is where they request that certain amount of bandwidth to send their data across the network. So they're reserving that resource. It requires end-to-end signaling. So all the end device, the two end devices and all the devices in between need to communicate and say, okay, we're going to allocate this much bandwidth to this communication path. It's on a per request admission control. So every time you need to send data, it's going to make a request. It does classifications, it has our policies there, and it does queuing and scheduling for us. Now, the drawbacks, very resource intensive because we have to have that communication to do the reservation of the bandwidth. There's also that requirement for continuous signaling. Are we still using the bandwidth? Yes, we are. We got to keep that reserved. This flow-based approach definitely doesn't scale to large implements, such as the internet. And the other thing here, the integrated services model very often is not deployed by itself. Here's an example of the integrated services model. We have two PCs here. They're both quality of service aware, so you need to go and do some configuration on each end. When you have that configuration, they communicate with each other, and then they also do this dynamic reservation or dynamic resource reservation here. All of these devices here have to participate in this communication to reserve that bandwidth so that traffic can get through there for the data that needs it. And so because of that communication, once again, it doesn't scale very well. It's resource intensive. But this is an automatic process. Once you have it configured, you turn it on and you're good to go. The differentiated services model, the benefit here is it scales really well. It scales to large networks. It's defined by its classes. The packets are marked directly inside of the packets. So when we mark those packets, it's in the packet. And then as it travels through your network, we can look at that marking and identify what type of traffic it is. We use a network-based application recognition, NBAR. And that uses 6-bit differentiation service code point, a DSCP, in the IP header. So we set some information in the IP header about how that data should be serviced through our network. Now, the drawbacks, we don't have that guarantee of service quality. There is no guarantee. Each device looks at that packet header, says, okay, you have this type of quality of service assigned to you, you're going to go on. Now, if that device is full, it may not make it through. But setting this up, you got to have a complex set of mechanisms here to work in concert throughout your entire network. So you have to do some configuration, some setup here, manually go in and make those settings. Here's an example. Your two end devices, they are unaware. You don't have to do any configuration. You just plug them into the network. Then when you have your routers here, you have manually configured these. When traffic comes in, the router then classifies it, and as it travels through the network according to your routing protocol or your routes, it will then be processed according to the quality of service in that header field on how fast to get through your routers to get to its destination. Once again, you have to manually set this up. It was my pleasure to provide you with this wonderful episode on quality of service models. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.